Linear programming is a method by which engineers, statisticians, stockbrokers, insurance carriers, and many other types of analysts calculate the optimum situation. There are infinitely many ordered triples that satisfy a single linear equation in 3 variables. Their job is finding a single ordered triple that satisfies the linear system. Hi, my name is Tom Atwater. This lesson discusses various ways to do just that. Let's start with examining the possible systems that we have. Okay, so when we have 3 variables, we have 3 planes. And if they intersect in this particular manner, then they have 1 point of intersection, as I've outlined in the middle. The 3 planes, if they were intersect like this, then it gives us a line which has the points in common. And if they intersect like this, they actually all 3 coincide with each other, then all the points are in common. Down the bottom, we have 3 examples of where there are no points in common. In this case, none of the planes intersect at all. In this case, 1 plane intersects each of the others, but there are still no points in common. And in this particular example, each plane intersects the other 2, but there are still no points in common. Let's look at the steps involved with solving a system of equations. The analytic solution of systems in 3 variables. Step 1, eliminate a variable from any 2 equations. Step 2, eliminate the same variable from a different pair of equations. Step 3, eliminate a second variable from the resulting 2 equations in 2 variables. Step 4, solve the resulting linear equation in 1 variable. And finally, step 5, find the value of the other 2 variables by substitution. Let's do an example. We're going to solve the system 3x plus 9y plus 6z equals 3, and 2x plus y minus z equals 2, and then x plus y plus z is equal to 2. So the first thing that I need to do is write those 3 equations down on the board so that we can then begin to eliminate one of the variables. So I would have 3x plus 9y plus 6z is equal to 3. And that I'm going to call equation 1. Then 2x plus y minus z is equal to 2, and that is equation 2. Then I have x plus y plus z is equal to 2, and I will call that equation 3. We can eliminate z by adding equation 2 and equation 3 together. These 2 equations, if I add them together, you will see that z gets eliminated, and we get what I will call equation 4, which is 3x plus 2y is equal to 2 plus 2 for 4. And I'm going to refer to that as equation 4. Okay, so now what I want to do is multiply equation 2 by 6. And the reason for that is then if I add it to equation 1, the z's will cancel out. So let's take and multiply equation 2 by 6, which would give me 12x plus 6y minus 6z equals 12. And I am going to add equation number 1 to that. And that's going to give me 15x plus 15y equals 15. And I will refer to that as equation 5. Now, what I can do is multiply equation 4 by negative 5, and then add that to equation 5. So here's equation 5. I'll leave it right there. But now let me take this one and multiply it by the negative 5. That'll give me negative 15x minus 10y is equal to negative 20. I will add those two equations together, and of course the x's will drop out, and it will leave me with 5y equals negative 5. That will give me y is equal to negative 1. Now what I'm going to do is substitute that negative 1 back into equation number 4. So let me move over and do that over here. I have 3x plus 2 times y, which is negative 1, and that is equal to 4. That means that 3x minus 2 equals 4, 3x equals 6, and x is equal to 2. I can now take x is equal to 2 and y is equal to negative 1, and let me plug them into the third equation, x plus y plus z equals 2. So x is equal to 2, y is equal to negative 1. 2 plus negative 1, of course, is 1, which I subtract from both sides, and I get that z is equal to 1. So the solution set for this particular problem is going to be 2, or the ordered triple 2, comma, negative 1, comma, 1. And that is the solution. Now it's time for you to try a problem. I want you to solve the following system analytically, which is the method that I just showed you. X plus y plus z equals 2. 2x plus y minus z equals 5. And x minus y plus z is equal to negative 2. Pause the video to work on this problem. When you are finished, restart the video to check your solution. All right, let's find out how you did on that particular problem. Let me write the 3 equations on the board and number them so that we can refer to them. And we have x plus y plus z is equal to 2, and I will refer to that as equation 1. Then I have 2x plus y minus z is equal to 5, and that's equation 2. Then I have x minus y plus z is equal to negative 2, and that I will refer to as equation 3. Let's start off by adding equations 1 and 2 together, because that will eliminate z. And let me check them so you know those are the 2. So it's 3x plus 2y equal to 7. And that I'll refer to as equation 4. Now, let's add equations 2 and 3 together. For equations 2 and 3, we get 3x. And look what happens. The y's cancel out, the z's cancel out, and we get 3x is equal to 3. And I'll still refer to that as equation 5, but what happens is we just need to solve this equation, and that's going to give me x is equal to 1. And what I can do now is substitute that into equation number 4. And that's going to give me 3 times 1 plus 2y equals 7. That's 2y is equal to 7 minus 3, which is 4, so y is equal to 2. And now what I can do is substitute x equals 1 and y equals 2 into equation number 1, right up here, equation number 1, and we'll be able to solve for z. So it's x, which is 1, plus y, which is 2, plus z is equal to 2. And what that tells me, of course, add those 1 and 2, subtract 3 from both sides, and I get z is equal to negative 1. So the ordered triple, the solution to our system of equations, is the set, the ordered triple, x equals 1, y equals 2, and z equals -1. If that's the solution you got, then you're well on your way to understanding how to solve these systems analytically. Let's look at another example. Solve the system x plus 2y plus z is equal to 4, and 3x minus y minus 4z is equal to -9. Well, the first thing to realize here, of course, is you only have two equations, and there are three variables. So geometrically speaking, what's going to happen is when these two planes intersect, we get a line. And thus, there will be infinitely many ordered triples in the solution set representing the points that lie on that line of intersection. Let me write down the two equations on the board, and then we can begin to solve them. So the first equation that I gave to you is x plus 2y plus z equals 4. And I'm going to refer to that as equation 1. Then I have 3x minus y minus 4z is equal to -9. And that's equation 2. Let's multiply equation number 1 by -3. And then we'll add it to equation 2. So I'm going to multiply this by -3 and put it right below. So -3x minus 6y minus 3z equals -12. And then, of course, the point of that was that the x's would drop out, and I get -7y minus -7z equals -21. And as you can see, they have a common factor of 7, so that I can change this to -y minus z equals -3. And then further, I can say that z is equal to -y plus 3. Okay, so now what I want to do is solve equation number 1 for x in terms of z. So let's take equation number 1 and solve for x in terms of z. So equation 1, x plus 2y plus z equals 4. And we're going to solve that. X is equal to, I've got to subtract both of these. And then what I'm going to do is make a substitution, because we can take and from this equation, plug it in here to figure out what x is equal to. So now x is going to be equal to -2y minus z, which is -y plus 3, plus the 4. Okay, what that gives me is x is equal to, well, when I distribute the minus sign, that becomes plus y. When I add that to -2y, we get -y. And then the -3 added to the 4 leaves me with +1. So I get x is equal to -y plus 1. So the solution set is dependent on the value of y. And this is what the solution set would look like. Is the ordered triple dependent on y, of course, -y plus 1, comma, y, comma, -y plus 3. So it's dependent on the value of y. For example, if y were equal to 1, then x would be 0, y would be equal to 1, and then z would be equal to, plugging a 1 in here, z would be equal to 2. So the ordered triple would be 0, 1, 2. All right, let's solve an application of a system with three equations. Let's take a look at this example. An animal feed is made from three ingredients: corn, soybeans, and cottonseed. One unit of each ingredient provides units of protein, fat, and fiber, as shown in the table. How many units of each ingredient should be used to make a feed that contains 22 units of protein, 28 units of fat, and 18 units of fiber? And in the table, you see that we have corn, soy, and cotton, and protein, fat, and fiber, and the numbers that are associated with them. I'm not going to read them because I'm about to use them to create our equations. So we'll refer back to those numbers as I build my equations. The way I'm going to start is I'm going to say, let's let X equal the amount of corn. Then I'm going to say, let Y equal the soybeans. And we will let Z equal the amount of cottonseed. All right, so if we look at protein first, so I'll just put P for protein, we know that it's going to be 0.25x, because that's the amount of protein in a serving of corn, plus 0.4y, 0.4 being the amount of protein in soybean serving, plus 0.2z, and that would have to equal a total of 22. Next, let's do fat. For the fat, we would have 0.4x plus 0.2y plus 0.3z, and that equals 28. And then for fiber, we would have 0.3x plus 0.2y plus 0.1z, and that has to total 18. I'll refer to each of these equations in their order, equation 1, 2, and 3. One of the things that I want to do first, though, is clear these decimals out of here in all three problems. So in the first case, we would have to multiply equation 1 by 100. That's going to give me 25x plus 40y plus 20z equals 2200. I would have to multiply equations 2 and 3 by 10. And when I do that, I get 4x plus 2y plus 3z equals 280. And then this equation by 10 gives me 3x plus 2y plus z is equal to 180. And again, we'll refer to these as equations 1, 2, and 3. Now, if you use the methods that we examined in example 1, what you would do is find that X is 40 units of corn, that Y turns out to be 15 units of soy, and that Z is equal to 30 units of cottonseed. And that would be the solution to that application. All right, next, we are going to apply systems of linear equations to a regression problem involving a quadratic function. Let's look at the details of this example. Find the equation of the parabola with a vertical axis that passes through the three data points 2, 4, -1, 1, and -2, 5. Well, this would be the equation of a parabola is a quadratic equation. and it's going to have the form y equals ax squared plus bx plus c. And what we would do is substitute each of the ordered pairs into that equation. So let's take a look at that. Y equals ax squared plus bx plus c. And I would take my first ordered pair, which is 2, 4. 2 is x, 4 is y. So this would be 4 equals a times 2 squared plus b times 2 plus c. Of course, I should simplify that a little bit, and I will in a moment, but let's look at plugging in the next point, -1, 1. That would be 1 equals a times -1 squared plus b times -1 plus c. Again, we'll simplify that in a moment. The third point is -2, 5. So that would be 5 equals a times -2 squared plus b times -2 plus c. Let's simplify each of these equations. If I take this equation and start by writing the a first, I'm going to get 4a plus 2b plus c equals 4. And that, of course, will be referred to as equation number 1. The second equation, it would be -1 squared is just +1. So we have a, and then minus b plus c is equal to 1. And that will be referred to as equation 2. For the third point, we simplify this. We're going to get 4a minus 2b plus c is equal to 5. And that's equation number 3. Now, we're going to eliminate c first by using equations 1 and 2. And the way I will do that is by simply subtracting equations 1 and 2 from each other. That's going to give me an answer, 4a minus a of 3a. 2b minus a negative b would be 3b. And then 4 minus 1 would be 3. Well, of course, I should point out that this simplifies to a plus b equals 1. I will refer to this as equation number 4. Okay, now we're going to use equations 2 and 3 to eliminate the c value. And the way I will do that would be to take equation number 2 and 3 and subtract them. So, a minus 4a is negative 3a. Negative b minus a negative 2. So that would be really a positive 2b. So that gives me plus b. And then the c's will, of course, drop out. And 1 minus 5 is negative 4. And that's equation number 5. All right, so now I can take equation 4 and 5. And if I simply subtract those two, I can eliminate the b. So I have a minus 3a. That's going to give me 4a. The b's drop out, and I have 1 minus a negative 4, so that's 1 plus 4, which is 5. So a is equal to 5/4. So now I need to take that a and plug it back into the equation a plus b equals 1. So 5/4 plus b equals 1, so b will equal negative 1/4. Now I can take my a equals 5/4, my b equals negative 1/4, and plug them back in to one of the original equations. I'm going to take equation number 2, which says a minus b plus c equals 1. And that's 5/4 minus a -1/4, so that's plus 1/4. So that gives me a total of 6/4 plus c equals 1. Of course, 6/4 reduces to 3/2, which I subtract from both sides and come up with c equals -1/2. So I go back to my equation of the parabola. I have a, b, and c. I plug those into y equals ax squared plus b. So y equals a x squared plus, and actually, sorry, it should be plus b, but b is negative, so it's minus 1/4 x, and then plus c, but c also is negative, so I get -1/2 at the end. So here's the equation of my parabola. Y is equal to 5/4 x squared minus 1/4 x minus 1/2. Well, what I'd like to do is go to the graphing calculator and show you how to do a regression to find this answer. All right, I've keystroked in a number of all of the keystrokes that we're going to have to use. And what I have here is software that's an emulator. It emulates the TI-84 Plus and the TI-83 Plus. They have the same screen output and they also have the same keypad. So whichever one you're using, you can follow along with me. So over here, I have all of the keys that we need to press in order to do this regression. So we start by pressing the Stat button, then I make sure that all the lists are cleared, so we clear list number 1 and enter it, so that's cleared out. I'm going to hit the Stat button again and clear out list number 2 and make sure that there's nothing in there. All right, and then let's go back to the Stat button and we're going to edit the list. So here are my lists, there's nothing in there. I am going to enter in to the window because I want to make sure that my window is set up to take this regression. So we're going to do -4.7 as the minimum, 4.7 as the maximum. For the y minimum, -1.1, and for the y maximum, 7.1. Let's go back to the Stat key, then hit Enter, which allows us to edit the lines. I'm going to plug in 2, which is my first x value. Then I'm going to plug in -1, which is my second x value. Then I'm going to plug in -2, hit the Enter key to get my third x value. Now I'm going to move over to L2, list number 2. And that's going to be my y values that correspond to my x values. So this is going to be +4. This one will be +1. And this one will be +5. Let's return to the Stat button. And now we want to calculate. So we move over to Calc. And we want to do a quadratic regression, which you should notice is number 5. So we're going to punch the number 5, and it comes up and tells us we're going to do a quadratic regression. So we hit Enter. And it'll take a moment, and there it is. It comes up with y equals ax squared plus bx plus c, and it tells us that a is equal to 1.25, b is -0.25, and c is -0.5, which of course agrees with the fractions that we came up with. Let's go ahead now and continue and graph the function. So here we have y equals 1.25x squared minus 0.25x minus 0.5, and then hit graph. And of course, it will show us the graph of a parabola, which gives us the regression that would go through those 3 points. In this case, it was much easier to use the graphing calculator to find that equation. In this lesson, we explored linear systems in 3 variables. Be sure to work the exercises that your teacher assigns, and we'll see you next time.